All right, we are recording again. Those of you listening at home, you didn't see my first attempt, but hi. We are reading off the answers to 3A-2.
The post the wrong one's like 8 seconds long.
Here we go. Number one, gentlemen. Everybody focusing. Number one, x equals -7. And that's it. If you put it in interval notation, you it looks, this is one of the rare ones where I wouldn't require interval notation because it's only a single value. Could you put it in interval notation? Yeah. It would look like this. It looks kind of dumb. It's all the numbers from 7 to 7, including 7, which basically means 7. So I did say interval notation, so technically that was it, but I will accept on that one, x equals 7. Let me clear the rest of this off. The other ones are going to be normal intervals. So number two, two intervals from -infinity to -3, and from -1 to infinity, round brackets everywhere. If they don't have an equals in their inequality, then it's never going to have square brackets because they're not asking for the endpoints. Make sense? Number three, two intervals from -infinity round bracket to -1 square bracket. That's the first one. Then union from 3/2 square bracket to infinity round bracket. Any repeats of number three? All right, number four, there are three intervals. All of these are round bracket. From -infinity to 1, from 3/2 to 2, and then from 3 to infinity. Number 5, two intervals, round brackets for everything. From -infinity to 2/3, and then from 5 to infinity. Number 6, there's one interval, round brackets, from 1 to 5. And it repeats on the front page. All right, number 7, two intervals, round brackets on everything. From -infinity to -4, and from 3/2 to infinity. Number 8, there are two intervals. Some of these are square. So the first one is from -infinity round bracket to -8 square bracket. Then union. Next one is square bracket -3 to 3 square bracket. Square bracket on both sides. Any repeats so far? Okay, number 9, there's one interval from -6 to 5 round brackets on both. Number 10, two intervals, round brackets on everything, from -infinity to 1, and from 3 to 4. And that should be it. And it repeats on the whole thing. All right, I am open to questions. Any of those you want to see worked? Yeah. Number 6, let's take a look. From -x plus 5 times, now this is already factored, and we're going to have greater than 0. I'm going to kind of turbo this one because we've got a lot of new stuff to cover today. There are two roots in this thing. There are no vertical asymptotes, no holes. See, because we're not dividing by anything. So these are roots. Set them both equal to 0 to find the roots. This one is pretty easy to see, it's x equals 1. This one's not quite as easy to see, but it's going to be x equals 5. So we've got, I'll prove it to you. -x plus 5 equals 0, subtract 5, and then divide by -1. Okay. So x equals 5 and x equals 1 of the roots. Let's do plus minus notation. Focus please. So 1, 5, single root, single root. So you got 3 regions, A, B, and C. I'm gonna try 0, because it's easy. That's region A. And then there are 2 parentheses for y. Plug in a 0 for this, it's positive. Plug in a 0 for this, it's negative. So region A is negative. Single root does switch the sign. Single root switches the sign again. They wanted everything greater than 0, which means positive, so they wanted region B. Did they want the ends? Nickel.
No,
They did not, correct. Otherwise it'd be greater than or equal to. These would be safe to give them for ends, but they weren't interested in them. So the final answer should be x belongs to round bracket 1, comma 5, round bracket. Does that make sense? Any others you want to see? Everything that you abbreviate that on a test? Any others? Get these screen banshee things from downstairs, I just wondered. No other questions? Going once, twice, thrice? All right, take out your notes, please. I'm going to do a bit of a review from last year and from a little bit of this year. We have been graphing inequalities solutions, but we haven't been graphing inequalities. Oh, let's see what you remember. I'm going to give you 2 problems. One is a really old review problem. Y is equal to 3/4 x plus 1. I will, just for reference, be assuming that you know the 4 forms of a line. Slope intercept, standard, point slope, intercept. If any of those are foggy, go back in your old notes, brush up on them, or come talk to me, or talk to somebody who remembers them. This is slope intercept form. Can somebody quick talk me through the sketch of that? Good.
Just put point at 1 and 0 on y.
On the y-axis, yeah. So the y-intercept is 1, okay?
And then you go up 3 over 4.
Correct. You rise 3, run 4, and that should do it. Does that seem familiar? Now, how do you do this? How would you graph y is less than 3/4 x plus 1? You notice the formula is the same, but what's different? How do you do this? Go.
Well, it's a dotted line, open dots instead.
Right. Less than means I don't want equal. So there are going to be open dots. And it's going to be an open border. That has absolutely nothing to do with politics, by the way. It just occurred to me, I'm like, oh, this could be awesome. Open dots, open border, that sometimes means dotted. Careful. Careful. So here's what it looks like. Maybe up here. You do the exact same dots. Y-intercept of 1, but it's an open dot, it's not a closed dot. Same thing up here, you rise 3, run 4. But it's another open dot. The line is not going to be a solid line. It's going to be a dotted line. There is something still missing. Katie, what is it?
You need to shade one part,
Shading. How do you tell which way to shade?
which is test a point.
Test a point, as long as the point is not what? On the line itself, right. Otherwise we wouldn't know which way to shade. What's a nice easy point to test if you can do it?
0.
0, 0. Do me a favor, put a little X at 0, 0. We're going to test 0, 0. How? Take over Gordon. How do you test 0, 0?
Plug it in.
Plug it in. What does that look like when you do?
0 is less than 3/4 times 0
What does that simplify to be?
1.
Yeah, 0 is less than 1. Is that true or is that false? That's true. So where would I shade if this is true?
Towards the 0.
Yes. The test point is true, you shade toward it. If the test point is false, you shade away from it. Which has the entire moral of life in one math problem. If something's true, you run toward it. If something is false, you run away from it. Everybody did that, original sin would be gone. But nobody listens to mathematicians. So, questions? All right. Let's see if you remember this. Go ahead and write that down. Y equals 2 parentheses x minus 1 parentheses squared minus 5. Nate, take this one and start. What shape are we talking about? Parabola. How do you know? It's squared, right. Can you tell me what form that's in? There were 2 different forms, well, 3 forms we played with, but 2 main ones. That's a form of a line, though. There was vertex form, standard form, and x-intercept form that we played with. Which one does that look like? Point slope is a line. What's that? All right. Let me refresh your memory. There are 3 forms of a quadratic that we covered. The first is vertex form. Y equals a parentheses x minus h parentheses squared plus k. If you do not have that ready in your memory, write it down. That's vertex form. Hence the name, it gives you the vertex at h comma k. And then a is the height multiplier. Does that make sense? There's vertex form. I'm counting on you to know that for the test. You will have to know 3 forms of a quadratic for the test. First is vertex form. The second is standard form. If you remember the quadratic formula, that's the one it uses there. Standard form looks like this. Y equals ax squared plus bx plus c. A, B, and C are numbers, and it really doesn't give you much of anything useful. It gives you the y-intercept, I guess, technically. It's c. Because when you plug in x equals 0, you automatically get it. The third, which is a little more obscure, but we've seen it before, x-intercept form, is when you factor it. It's y equals a parentheses x minus x1 parentheses x minus x2, where x1 and x2 are numbers, and so is a. x1 and x2 are the x-intercepts, also known as roots, also known as solutions, also known as zeros of the function. Okay, let me circle that. So there are 3 forms of a quadratic we should recognize and be able to use. Which form is this? Nate? It's vertex form. There's one tiny thing wrong though, you see it? It doesn't quite match the form perfectly yet.
Is it because it's minus k and something?
Yes, what should it be?
Plus minus k.
Yeah, plus negative 5. So where's the vertex while we're at it? Blaze, take over. 1 comma negative 5, correct. Please do not put negative 1. The minus sign belongs in the formula, so don't steal it. This has its own negative. And then the height multiplier is 2. How do you graph that? Let me see. Will, where's the vertex, first of all?
1 comma negative 5.
1 comma negative 5. So 1 to the right, 5 down. What's the pattern for a normal parabola?
Over 1 up 1.
Yep, over 1 of 1,
Over 204.
Over 204, over 3, over 10,
Wait, what?
over 10.
Oh, up 100.
Very good, up 100, etc.
Yeah.
So over n, up n squared. Does that make sense? This is a height multiplier of 2. The normal pattern is over 1 up 1, over 2 up 4. What's this going to do?
Well, multiply the y.
Yeah, so instead of it's over 1 up 1, it's over 1 up
4. 2.
2, because it's normally 1. Now do the next jump. Over 2, it's normally 4.
8.
It's up 8. This is like 5. So you're going to go up to a height of 3, I think. So you're going to go up 8 spaces, both ways. And that should give you your problem. Does that seem somewhat familiar? If I gave you that on a test, would you be able to do it? So. Now a little spin on that. Does everybody get this one? The 3x, 3/4x, this one? I'm gonna have a problem that's almost the same. But do this. Y is greater than or equal to 2 parentheses x minus 1 parentheses squared plus -5. Same formula. I just changed the equals to greater than or equal to. Talk me through this. Back up. Where do you start? What form is it, first of all? It's vertex form. Where's the vertex? Correct. It's still a vertex of 1, (-5). Question, would that be a solid dot or an open dot? Solid. Why do you say that? Correct. Anything with an equal sign is going to be solid. What's the pattern? Megan, take over. What's the pattern if you have a multiplier of 2? Over 1, up 2. Correct. And then over 2. What's it normally? Oh, up 4. So what is it now? Up 8. Correct. It's going to be solid dot still. So go ahead and draw the solid border. At this point, it should look identical to the previous one, but there's one difference. Sam, take over. What's missing? The shading. Now, there are only 2 options for shading. There's shading above the border or below the border. Above the border would fill in the inside. Below the border would fill in this huge expanse on the outside. Which one? How do you tell?
You have to test it.
Test a point. Like what?
Can you still do 0, 0?
You can do 0, 0. Any point that's not on the border, it's fair game. Go ahead and do that for me if I'm testing 0, 0.
So it'd be 2 parentheses 0 minus 1. First 0.
Yeah, 0 is
Greater than or
greater than or equal to 2 parentheses
0 minus 1.
0 minus 1 squared plus
-5.
-5. Simplify this for me. What's 0 minus 1?
-1.
-1. -1 squared?
Is 1.
1 times 2?
It's 2.
2 plus -5?
-3.
0 is greater than or equal to -3. True or false? Think temperature, it might be easier. Is 0 warmer than 3 below?
What's equal?
It's greater than or equal to. Either one would work. It's kind of like saying
Yeah.
if somebody is 18 or older, they don't have to be exactly 18 to get in. So go ahead. Is it true or false?
It's false. I mean true. Sorry.
Which one?
True.
True.
Sorry,
Correct. 0 is greater than -3, so that's the part that happens. So which way should I shade?
The inside.
Inside. Correct. Your final answer should look like this. Whenever you do an inequality, the only way to do it is to graph. I'm going to get a spin on that in a minute. But does anybody have any questions so far? We did a quick review of how to graph parabolas, and then an equally quick review on how to shade inequalities. Everybody okay so far? Let's see if you can do this. way back when, first year algebra. 4 on the floor, please. Thank you. Go ahead and write that down. X plus y equals 7. X minus y equals 5. I would like you to solve. Anybody talk me through it? Go.
So you set 1 equal to y or x, and then plug it into the second equation?
Yes, there's one method called substitution, where if you get a letter by itself and plug it in, it should work. That is one method. I'll save that for the next one. There is another method. Go.
You can just add the two equations together.
Ray, what's that called? You remember? Substitution? Elimination, correct. Elimination is trying to get something to cancel. Jill, take that.
We just added, so this is 2x
2x, and what happens here?
plus 0, we cancel.
And then equals 12. Keep going.
Divided by 2.
Right, what do you get?
X equals 6.
X equals 6. By the way, in about 10 seconds, you're halfway done with the problem. It's very fast. Substitution isn't too bad. It's a little slower. Abby, take over. I've got X. What do I still need?
Plug it in,
Yeah, take your pick.
top,
Sure. So what does it look like so far?
6 plus y equals 7.
Okay,
Y equals 1. You could do
correct. Yes. So y equals 1. Done. So everybody okay with that? Again, elimination is very fast if you can get it to work. If you can get something to cancel. Just to refresh your memory on what's actually going on behind the scenes. Does anybody remember how to graph x plus y equals 7? It's what's called standard form of a line. How do you graph standard form of a line? There's several options. Can somebody talk me through how to graph x plus y equals 7? Yeah.
Can you change it to slope intercept form?
You can do slope intercept form. Let's try it. What do you have to do in order to get that?
Subtract the x.
Yeah, get y by itself. So y equals, what would it look like?
Negative 1x plus 7.
Yeah, negative 1x plus 7. So I'll do a y-intercept of 7. And then the slope is down 1, right 1. Can anybody tell me where it's going to hit the x-axis? Katie. If the slope is down 1, right 1, where's it going to hit the x-axis?
That's 7.
7, correct. Down 7, over 7. So there's the first line. Does anyone remember that it's kind of a silly story that went with it, something called the Chubby-Yan method? It was something about finding the way to graph standard form. It's blank, comma 0, 0, comma blank. Plug in zeros and you'll get the two x and y intercepts. Pretend that y is 0, that's what the Chubby-Yan method is. You can take your hand and cover it up. You remember that? The goofy story that goes with that, okay. So pretend that y is 0 and x is 7. Pretend that x is 0 and y is 7. And sure enough, you're going to get the two intercepts. I'm going to try that same trick here. X-intercept is 5. But in this case, the y-intercept is negative 5. Because if you divide by negative 1, you get y by itself. And here's the other line. Quick question. Where do they cross? What comma what? Spencer.
6,
6 comma 1. Is there anything that might have told us that?
where they intersect?
Yep. The solution you got earlier, oh, I see what you're saying. The solution they got earlier is where they cross. When you solve two things at once, you're going to find out where they cross, where they're at the same spot. Does that make sense? So if you have any, this works with any graph, whether it's a line or not a line. I could have two parabolas and then do this trick, and I can find out where the two parabolas cross. It can get complicated because two parabolas could cross as many as 4 different places. Does that kind of make sense? Now, see who remembers this. Does everybody have the 3 forms of a quadratic? You will need them. Solve the following I'll just leave this as x6, y is 1. Go ahead and write that down. X plus y is less than 7. X minus y is greater than 5. Now we'd like you to solve. Last year, we covered multiple ways to solve equations at the same time, simultaneous equations. There was substitution, there was elimination, there was something called Cramer's rule, there was, when we were doing matrices, there was A inverse B. There are many, many methods to do that. What if they're not equations? What if they're inequalities? There is only one method that works. Go.
Graphing?
Graphing. The only way you can solve inequality systems, this actually might be a test question. When you're solving an inequality system, inequality is not equal, and then a system is more than one. The only way you can solve is by graphing. There is no other way. So let's graph. I'm going to do the chubby hand method on these. You notice there's no equals anywhere. What kind of dots are we going to have? Mary. Are we going to have solid dots or open dots on this one? Open dots. So on this one, where? Just ignore the bottom one for now.
On the y-axis.
Yep. And on the x-axis, correct. How about on bottom one? Where's the x-intercept? Pretend y is 0.
At 5.
At 5, okay. And then where's the y-intercept?
At -5.
Negative 5, okay. So we have dotted and dotted. But there's something missing. Mary, keep going. What's missing on these?
Like the point where they intersect.
We do, although we know that that's at 6, 1. But there's something still missing because of these.
The shading.
Shading. We got to do them one at a time. If you shade, you have to test a point. Take over, Josh. What's a good point to test if you can do it?
0,
0, 0. As long as it's not actually on the boundary, it's safe to go. Try 0, 0 in this. What do you get?
0 is less than 7.
Yeah, 0 plus 0 less than 7. True or false?
True.
That's true. Look at the downward line that had the 7s. Are you going to shade towards 0, 0 or away?
So you shade towards it.
It came up true, so you shade toward it. Everybody look up here. There are two ways to do a graph like this. You can just shade underneath this right away. I actually wouldn't do that. I would put little indicator arrows saying eventually we're going to shade down. Why am I doing that? Because if you have 2 or 3 or 4 of these things to shade, 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 I've tried this with the regular method of just and then all of a sudden, okay, I've got to shade down here, and then I've got to shade here. Your paper is going to rip by the time you do like 6 or 7 of these in a row. It's going to get darker and darker and darker, and then the paper is going to get white. So these little indicator arrows are going to say, whatever our final answer is, it's below this line. Can somebody test this one for me? Let me see. Austin, take over. Test the bottom one for me. You can still do 0, 0, I think. What would you get?
How do we get 0 is greater than 5?
Yeah, 0 minus 0 is greater than 5. True or false?
False.
That's false. So where would you shade?
Away from 0, 0.
Away from 0, 0. Look at the line with the 5s. You're going to shade away from 0, 0 because the test point came up false. Does that make sense? Does anybody see the region that's shaded twice? Nate, take over. There's, like, here's where the 2 lines cross, and there are 4 possible regions where they overlap. Is it the top, the bottom, the left, or the right? It's the bottom. What I'd like you to do, shade in the bottom region. That is your solution. What is your solution when you're doing equations? It's gonna be something comma something. Or you can just have x equals 6, y equals 1. Whenever you have inequality systems, you cannot do a single written answer. It's gotta be a graph. Partially because, let me know how many points there are in here? Yeah. Infinitely many points. It's like take a bucket of like blue paint and go splush on the bottom here, and it goes down forever. And even in this little cluster here, there's an infinite number of points, and then an infinite number of infinite number of infinite number of infinite thingies. All of these points would make this work. If I picked a point 10 comma negative 10, it'll work. I don't even have to plug it in. I know it's gonna work because it's shaded. 5 comma 1 negative 100, guaranteed to work. 5 comma 5, guaranteed not to work. It's not shaded both times. It's not in the final solution region. Does that make sense? Now, let me hand this thing out to you. This is homework 3C-1. I'm going to be splitting this this worksheet in half. It's not all due tomorrow. Half of it is. Yeah, no problem. For those of you listening at home, I will email you a copy.
Sayonara.
Yeah, the 3A. That's the next question. I think I'm gonna have this take priority. I think we're gonna stall the 3A until Friday. This is due tomorrow, and then the 3A is due Friday. If you have 3A done already, congratulations, you have no homework. So yeah, let me bump this over here. 3A, which is 1 through 31 odd on the worksheet, I'm gonna have that for Friday. And then homework 3C-1. I'm only gonna have you do, this goes up to 12. Yeah, I just want you to do 1 through 6 for tomorrow. Does that make sense? Okay, so for people watching at home, I'll write it up here too. The worksheet that I'm handing out right now, it's homework 3C-1. I just want you to do numbers 1 through 6 for tomorrow. And then we're gonna do homework number 3A for Friday. And then we're gonna do the second half of this from Monday. Does that make sense? So 7 through 12 Monday. So there's our homework coming in. That is it. Just a couple pieces of advice. Look at number 1, for example. What form are those? Yeah, those are slope-intercept form of a line. 1, 2, 3, and 4 are slope-intercept form. Be careful, some of the dots are solid, some of them are open. So some of the lines will be solid and some of the lines will be dotted. Make sure you know which is which. On number 5 and number 6, beware. Some of those are standard form. Actually, all of them are. There's 2 ways to do standard form. You can do Chebby-Hand method, or you can transform it into slope-intercept form. Whichever one works best for you, take your pick. Any questions? That should do it. You got about 10 minutes. Go ahead and plow away at those. Let me know if you get stuck. People watching at home, God bless you. See you soon, God willing. Stay well. This is my hand waving goodbye. Bye-bye.